Hey everyone, and welcome. Today, we are diving deep into the tech that powers tools like ChatGPT. We're talking about large language models. We are absolutely going to get into the technical nuts and bolts to see what really makes these incredible systems tick. So let's get right into it. So, have you ever stopped to actually wonder about that? I mean, when you prompt an AI to write a story or explain something super complex, what is actually going on under the hood? Well, I can tell you it's not magic, but it is a fascinating step-by-step process that we are about to completely unpack. Okay, so before we get into the really heavy stuff, let's start with a basic analogy. At its very core, an LLM is just a massively powerful prediction engine. It is constantly, and I mean constantly, calculating the most likely next word to follow the last one. The only difference is it's doing this with a depth of knowledge that it learned from a truly staggering amount of text. All right, first things first, let's break down this buzzword that you've probably been hearing everywhere. What exactly is a large language model? To really get it, we've got to look at each one of those words in the name. Okay, so large, that refers to the sheer scale of these things. We're talking billions, sometimes even trillions of parameters. And you can think of parameters as all the little knobs the model gets to tune during its training. Language is pretty obvious. That's its one and only focus, processing and creating human text. And finally, model. That points to its underlying architecture. For most of the LLMs you see today, that's something called a transformer architecture. It's a design that is just incredibly good at seeing the relationships between words, even across really long sentences. And that right there is the secret to their coherence. And believe me, the growth here has been absolutely explosive. I mean, we went from these early models like GPT-2 to the absolute game changer GPT-3 in 2020, which had a massive 175 billion parameters. But the real turning point was when ChatGPT was released to the public in late 2022. That single moment kicked off a wild technological race, with giants like Google and Meta jumping in. And that created the super competitive, fast-moving world we're seeing right now. And now for the fun part. Let's get technical and really look inside the AI's brain. How does this thing go from just a bunch of code to something that can write a whole essay? We're going to walk through that entire training process, right from the raw data to the dialogue you see on your screen. So the very first step is for the model to learn how to read, and it doesn't see whole sentences the way we do. Instead, it does this thing called tokenization, which is basically just breaking text down into smaller, more manageable pieces called, you guessed it, tokens. These are the fundamental building blocks of language for an AI. And this right here is a perfect visualization of that process. So our input, the quick brown fox, gets broken into these tokens. And from there, the model uses its core mechanism and, get ready because it's a mouthful, masked multi-headed self-attention. I know, but all it really means is that the AI can look at every single token at the same time and weigh how important every other token is to it. It's not just looking at the word that came before, it's understanding the entire context at once. And that's what makes it so incredibly powerful. So here's the most crucial point. Training an LLM is really all about teaching it to make incredibly sophisticated guesses. It looks at a sequence of tokens and then it calculates the probability for every single word in its huge dictionary of being the next one. By doing this billions and billions of times on these massive data sets, it just starts to learn the patterns, the grammar, and even the concepts of human language. But what it learns depends completely on its training data. For a long time, the thinking was just bigger is better. Just scrape the entire internet. But a recent study, and get this, it's called Textbooks Are All You Need, showed something pretty remarkable. It found that a smaller model, trained only on high-quality data, could actually outperform larger models that were trained on all that unfiltered web data. And the so what here is huge. It suggests that smart, curated data can be way more valuable than just raw size, and that could open the door for more efficient and specialized models down the road. All right, so a raw model that's just trained on web data is really knowledgeable, but it's not necessarily helpful or even safe. To get from that pure prediction engine to a helpful conversational assistant like ChatGPT, it needs one more crucial step, a human touch. This is done through a process called reinforcement learning from human feedback, or RLHF for short. This is the critical fine-tuning step that makes these models feel so aligned and conversational. It is a costly, time-consuming process where real people give direct feedback to shape the AI's behavior. They're basically teaching it to follow instructions and generate responses that are actually useful to us. And this beautifully illustrates how that feedback loop works. So the model generates a few possible answers to a prompt. Then a human rater looks at them and literally ranks them from best to worst. This feedback is then used to reward the model, tweaking its internal parameters so it becomes more likely to produce outputs like the ones we ranked highly in the future. And this brings us to a super critical technical point about data quality. You can read this quote here. Through a purely technical lens, the model's output is a direct reflection of its input data. It isn't inventing anything, it's just remixing and finding patterns in what it was fed. So if that training data is full of factual errors or just low-quality writing, the model is going to learn to reproduce those exact same flaws. It is the ultimate garbage in, garbage out problem. Another key limitation is something you've probably heard of, known as hallucination. This is when the model generates an answer that sounds completely confident, totally articulate, but it's factually wrong or just completely made up. This is why you must always verify critical information you get from an LLM. It's a powerful tool for sure, but it is not an infallible oracle. Okay, so we know how they work, and we know their limitations. Now, how do we, as users, actually get the best possible results out of them? Well, it is all about mastering the art of the prompt. Just look at the difference here. Tell me about dogs. I mean, that's so vague. The model has no idea what you really want. But that good prompt, it's a masterclass. It is super specific, golden retrievers. It asks for context, characteristics, temperament, health, and it even assigns a role, as if you were a veterinarian. This level of detail is what guides the model to give you a really high-quality, relevant answer. So let's just boil this down to some key principles. Be specific. Provide context. Give the AI a role like an expert or a historian. You can even provide a few examples of the kind of output you want. That's a technique called few-shot prompting. And for really complex tasks, just break them down into a sequence of smaller, more manageable steps. All right, let's zoom back out. We've seen how they're built. We've seen how to talk to them. Now, where is this technology actually being used out in the real world? And what are our responsibilities when we use it? Well, the impact is already massive. In healthcare, they're helping doctors stay up to date with the latest research. In a legal world, tools built on LLMs are automating research that used to take junior lawyers days to complete. And in tech and retail, they're speeding up code development and creating these really cool personalized shopping experiences. And this is all just the beginning. But what about one of the biggest problems we all see, that an LLM's knowledge is basically frozen in time and limited to whatever it was trained on? Well, that's where a really powerful technique called retrieval augmented generation, or RAG, comes in. This is an absolute game changer for making LLMs more accurate and current. So here's how it works. When you ask a question, a RAG system doesn't just send it to the LLM. First, it goes out and searches an external, up-to-date knowledge base. It finds the most relevant information, it adds that fresh data to your original prompt as extra context, and then it sends that whole augmented prompt to the LLM. The result is an answer that's grounded in current, verifiable facts, which massively, massively reduces hallucinations. And that brings us to our final and maybe most crucial point. These tools are unbelievably powerful, but they are not perfect. As users, we have a responsibility to think critically about the outputs. Always verify information, especially if you're using it for professional or academic work, and please always cite your sources properly. So, I'll just leave you with this question to think about. As these models get better and better at providing us with answers, our role is going to become less about finding information and a lot more about applying judgment, context, and ethics. You see, the AI can give us the data, but the wisdom, well, that still has to come from us. Thanks so much for joining me.